6-4 notes. These are actually my favorite in the whole unit, and I think a lot of you are going to like these problems as well. There's not much calculation involved at all. You just have to be able to pull the correct numbers from the table you're using. We have a box of information up here, and most of it's not super important, but I'll skim over it real quick. Probability of an event, we're still using probability here. This is the definition that we talked about yesterday. And then finding probabilities using a contingency table, that's what these tables are called here, contingency tables, two-way tables. Again, it doesn't really explain how to do it with this box, but it just gives some helpful information. When you see the word and, we'll do a few of those, that means you want to make sure you include both of the things that they tell you in the table when you're looking at it. It has to be applied to both labels, so apples and oranges. That will make more sense when we get to an actual example. Conditional probability, that's what some of these problems are called. You have conditional probability when you see words like given, knowing, and of. In this class, we're only going to see given and of, just an FYI. First problem, we use this table. We have people in this table. They're split up into multiple different categories. First, whether they're female or male. And second, by their job, family practice, pediatric, or orthopedics, all types of doctors. Before we get into a question, we need to make sure we understand every number that's going on in this table, specifically the totals. There are several totals in this table, and depending on the problem, you may need a specific total. So this 14 here, this is the family practice total. I'm going to abbreviate that. The 19, this is the pediatrics total, so I'm just going to put pedia total. $17 is the orthopedics total, so the ortho total. $26, that's going across. This is the female total. $24, this is the male total. This 50 right here, this is a very important number. As you can see, this 50 is where the two totals meet. This is called the total of the totals. This is the total of the entire table, the total number of people. We're going to use that number the most on the chart, but not in every problem. Now that we've got that squared away, let's do an actual problem. Number 1, what is the probability of selecting a female? Just in general. Pick anyone from the chart. What's the likelihood we're going to grab a female specifically? So this is P of female, just put fem for short, probability of female. I'm going to write out my fraction first with the description of what goes on top and bottom. This makes sure that we're looking at the correct numbers at all times. So we were probability of getting a female. On top, we put the number of females, because that's what we want. On the bottom, we just put the total. And when I say the total, I'm talking about the big total, the total of the totals. If I want a different total, then I'm going to specify later. So the big total is 50. Of the 50 people in this table, 26 of them are female. That's our probability. Do not forget to reduce. Reminder, your calculator can do that for you. 26, ABC 50 to reduce it. 13 out of 25. Reminder, if you do not reduce on the test or the quiz, you will lose credit. Always check. Number 2, what is the probability of selecting a person that is male and a family practitioner? That "and" is extremely important. So we're finding probability P of male plus, I'm going to abbreviate, FAMPRAC. Setting up my fraction over here. We want male and family practitioner. So number of male plus family prac has to have both. And again, we're just picking from anywhere in the table, so this is total. Nothing specific yet. Total is still 50. Looking at this chart, this table, what number represents male family practitioners? Has both things. Yes? Yes. Male family practice, they meet at the 5. The 5 represents the men who are family practitioners. That's the number we want. So 5 out of the 50 people in the table fit that category. Thank you. It's okay. Don't forget to reduce. This is going to give you 1/10. Yes. They're over there. I see them. Go ahead. Number 3, we're going to do another one of those. What is the probability of selecting a person that is a pediatrician and female? Similar question, just different categories. So P, probability of pedia plus fem for female. So on top, number of what we want, which is the pediatricians, plus female. Still over the total. Out of the 50 people on the table, what number represents female pediatricians? Or female pediatrics in the table? What number? 10. 10's correct. 10, these are the female pediatricians in the table. 10 out of 50, don't forget to reduce, simplify. 10 over 50, that's just 1/5. Any questions at this point? Four and five are slightly different types of problems. Start with 4. Given a male has been selected, find the probability the specialty is orthopedics. There is a phrase in here that's extremely important and it should catch your eye every time you read it. Given, that word is a signal that you should pick up. Given a male has been selected. That means I'm going to look only at the men in this table. Of the men, what's the probability I'm going to pull an orthopedic doctor from those people? So we're not looking at the total anymore. We're not looking at 50. We're looking specifically at the men only. So this means we're using the male total in this problem. Of that, we want the probability that the specialty is orthopedics. That's what we're looking for. Let's set up our fraction. We want orthopedics, number of orthopedics, of the male total. Start with the total. The male total is 24. Since we're only looking at male, we only care about the center row of the chart. Of these 24 men here in the chart, how many are orthopedics? 10 of them fit into the orthopedics category. So 10 of the 24. Don't forget to simplify. That reduces to 5 over 12. Number 5 does the same thing. Of the females, find the probability of selecting a pediatrician. That first word of, that's another signal word. So your two words that you look for is given and of. Those indicate that we're looking at a specific group, not just the whole table. So of the females, this is our female total. Let's set up our fraction. We want pediatricians, so number of, I'm just going to put pedias for short, over the female total. Going up to our chart here, we have 26 females total. Of these 26 females, again, at this point I only care about the female row of the chart. Of the 26 females, 10 of them are in pediatrics. So 10 out of 26. Which reduces to 5/13. Questions on 4 and 5 before we move to the back side? Okay. Flip it on over. We're going to do another one of these, but we only have to answer one question here. Number 6. In a class of students, the following data table summarizes how many students play an instrument or sport. What is the probability that a student chosen randomly from the class does not play an instrument given, circle it, they play a sport? Sometimes we'll put that information at the end of the sentence instead of the beginning, so keep an eye out for it. So that means this is our total. Given they play a sport, and just for context, let's look at those categories real quick. Plays a sport versus does not play a sport. So we're looking at plays a sport total. That's the number we care about in this problem. We're on the back side of the new notes. Yeah. Thank you. So let's take a look here at our table. We have plays a sport, does not play a sport, plays an instrument, does not play an instrument. What is very clearly missing from this table? Yeah? Totals. The totals. I told you yesterday, we like to leave the totals off to give you a little bit more to do here. So we have to find the totals first. We have to find the totals of the horizontals and of the verticals. So we're going to have two totals we have to find. Let's start with the vertical totals. 5 plus 2, that's going to give me 7. 10 plus 11, that's going to give me 21. I'll come back to this guy here in a sec. I'm going to go across now. 5 and 10, that's 15. 2 and 11, that's 13. Don't forget about this number here, the total of the totals. It's really important. Now, what's nice about this number is I can get it two ways, which means if you make a mistake, you're more than likely going to catch it. 15 and 13, that's 28. Check across real quick. 7 plus 21, that is also 28, so it works. It needs to work in both directions if it's correct. Now that our table is complete, we can actually answer the question. So we want to find the probability that we choose someone who does not play an instrument of the plays a sport total. So let me set that up. And this is going to get a little wordy, my apologies. Number of does not play, I'll abbreviate instrument. Does not play instrument over the plays a sport total. So we only need one of the totals here. We need the plays a sport total. Plays a sport, that's 15. And I'll write that next to it as well. I want to know out of these 15, how many do not play an instrument? So I'm looking only at the top column, or the top row here. Of these 15, 10 of them do not play an instrument. 10/15. Don't forget to simplify. This reduces to 2/3. questions on number 6 before we move on to the Venn diagram problem below? By the way, I did not go through all the labeling of the totals since I only needed one total. There's one question. Also, I was lacking space. All right, let's move on to the Venn diagram. Venn diagram, 2 circles that connect at some point. Hopefully you are familiar with the concept of a Venn diagram, how it works. This is really important to discuss because it does appear on the SAT, more than likely it will, and you guys are taking that in 2 weeks. Also, there are parts of the Venn diagram that you probably haven't thought about, or different ways to look at a Venn diagram. You haven't been challenged to that level yet, so that's what this is going to do. I'm going to read the problem. A survey was conducted in a neighborhood with 128 families. This is a total. The survey revealed the following information. And when they say that, they're referring to the Venn diagram. All the info's in here. Now the letters are explained over here. Let C be the families with a credit card. Let L be the families with a car loan. Let S be the total number of families, which we now know is 128. So I'll fill that in. First question, how many families have a credit card? I'm going to go ahead and tell you now the answer is not 45. You have to think a little harder than that. Anyone want to throw out an answer? Yes? How did you get 106?
The ones that are just in the circle of with the credit card, and also the one in the middle, which has both the credit card and a card.
Yes. Everyone inside of the C circle has a credit card, so that is the 45 and the 61, not just one or the other. So you do have to add those. So this is the whole C circle. That's what they're asking for. So we're going to take 45 and 61. We'll add them together and get 106. That's 106 families. Thank you. Number 8, how many families are trying to pay off a car loan? It's the same type of question, but with the L circle. So this is asking for the whole L circle. And again, we add the numbers inside the L circle, 61 and 12. And that'll be 73 families. Number 9, find the probability that a randomly selected family has a credit card. No tricks up my sleeve here. This is as straightforward as it looks. So we're going to make our fraction. We want the families with credit cards. So this is number of credit card over the total, just out of all the families. And mentor at the notation over here. This is probability of C, C for credit card, just like it is in the Venn diagram. Let's start with the total. There's 128 families. They told us that at the beginning. And we want to put the number of families with credit cards on the top. That's 106. That's why we did 7 and 8 first, so that we have these numbers. As always, do not forget to simplify. This reduces to 53 over 64. 2 more. Number 10. Find the probability that a randomly selected family has both a credit card and a car loan. So this is the probability of C plus L. We want both of those. So on the top, we want the number of credit card plus loan. We want both. Again, over the total, nothing specific here. Out of the total, out of the 128 families, not a trick question at all. How many families have both credit card and a loan? Yes. 61. It's that intersection. That's what it means. It's in both categories, both in the C and the L. So that 61 is what goes on top. You can try to reduce this in the calculator. It won't change the fraction. This is actually as simplified as it gets. This is our answer. One more, and I doubt you've ever seen this kind of question with the Venn diagram. Find the probability that a randomly selected family has neither a credit card nor a car loan. So this is the probability of neither. Setting up our fraction here. We have number of neither on the top over the total. Our total is still 128. Let's look at the Venn diagram. How many families have neither of these, Devin? 10. I'm sure quite a few of you probably noticed that 10 and wondered what the heck does that mean. I doubt you've ever seen this. You're used to just seeing a Venn diagram with numbers in it, nothing more than that. So if you have a family who doesn't go in either side of the Venn diagram, it can't go in the Venn diagram. So we put them outside the Venn diagram. This represents the 10 families that were interviewed but had nowhere to go. So that's why there's a box around this Venn diagram, so we're still including those 10 families who don't fit in a category. So this 10 represents the neither category. And we have 10 out of 128, which does reduce to 5 out of 64.